So, what's the story here? This is an old 3D printer from my friend Jan over at Reds 4.0. He handled it over with a mission. Turn this into the fastest Prusa i3 on the planet. It served him well for years, loyal and reliable, but now it's time to wake the beast. Jan built some of the most extravagant 3D printers and mechanisms out there. So being asked to upgrade his machine, that's an honor and a challenge, because I have just a few days for that. The printer is meant to become a test rig for one of the most insane extruders ever designed. But more on that over on his channel. One more thing. He gave me a very specific design brief: wolf in sheep's clothing. That means no RGB, no fancy mods. Keep it stock, but on the outside. Even the original LCD display has to stay, but underneath, pure unapologetic power. So this is the Manta M5P, the board that is going to be used in the printer. I already set the jumpers right for the new stepper drivers, and I've also got the compute module number 4 from Raspberry. Sadly, I bought the version without Wi-Fi. Oh, and don't forget the diag jumpers for the X and Y axis, because we are using sensorless homing on them. I think this is going to be a game changer for future builds, because it's so neat and well designed to fit right in here. Perfect. Mainsail is already flashed on the SD card, so we just have to configure and then we are ready to go. This is a case for the Manta to fit right on the printer. If you're interested in the STLs, this is from Printables, and a link is in the description. So finally the brackets are finished, except for one, because the print has failed. But let's print it again. So I have stripped down the Power Panic PCB from the socket, and this will fit perfectly in here. This is the new power box with the switch and the socket, and this will be mounted over here. I'm very satisfied with the fit, and this is more stable than I thought of. So yeah, let's go on. Yep, and it doesn't fit. So I have to take some of this clamp here. I'm not going to reconstruct because it's just a tiny bit. Yep, perfect. Spot on. I hope it's not a problem that this stepper motor is just held by 2 screws, because there's a lot of power going on here, a lot of torque. Otherwise I have to make this clamp out of aluminum. So the first motor is in. Let's get started with the other one. So it's now time to get rid of the old box here. I've been looking into the pinout of the original Prusa display, and it's actually pretty straightforward once you map it out. One connector handles the display signals, the encoder and the piezo, while the other one is mostly for the SD card, which isn't really needed when running Clipper anyway. The reset and encoder pins are easy enough to identify, and with the right configuration it should be possible to hook everything up to the new board. Hopefully it'll all play nicely together once it's set up. Let's have a look. At first, the display was just showing complete garbage. Nothing readable at all. But I found a post on GitHub where someone mentioned that you just need to tweak the display delay time. So, by changing it in the main configuration, basically from 40 to 50 in the last 2 digits, it suddenly started working perfectly. The only downside is when you update Clipper, that change gets overwritten. So yeah, never update a running system, that's the key here. Oh, and don't forget, you need to flip the pin header housings, otherwise the signals just won't go where they're supposed to. I also added an RP2040 to read the thermistors that are built into these stepper motors, mostly so Jan can do some better debugging and also to keep the motor mounts from literally melting. The setup works through a simple voltage divider connected to the ADC pins of the RP2040. Basically, the thermistor changes its resistance with temperature, which affects the voltage that the ADC reads. So by measuring that voltage, we can calculate the actual motor temperature in real time. It's a pretty simple circuit, but super useful for monitoring and keep everything safe, especially when you start pushing those motors a bit harder. Once the build was finished, we went through all the parameters together and got everything properly configured. After that, Jan designed a custom mount for the dual extruder. So guys, you've seen it built by me, and now we're going to see it running. Huge thanks to Jan for trusting me with such an awesome project. It was a lot of fun to work on, and I really hope he's happy with the result. Hopefully, this setup will help him in developing even more high-end extruders in the future. If you have any questions or ideas, feel free to drop them in the comments below. I'd love to hear your thoughts. And if you enjoyed this project and want to see more builds like this, make sure to give it a thumbs up, subscribe to the channel and stay tuned for what's coming next.